Hello viewers, in today's session we are going to discuss another important problem from domain of functions, and in this session we are going to find out the domain of this function f of x is equal to cosine inverse, and here we have natural log of x minus 2, right? So here we'll try to find out the domain of this function where we have the inverse trigonometric function, that is cosine inverse, and here we have the logarithmic function. So let us take natural log of x minus 2 as theta. So here we'll make this assumption, that is the theta is equal to natural log of x minus 2. So now we can write this function f of x is equal to cos inverse theta, right? Okay, now from inverse trigonometric functions we know that the range of cosine inverse theta is given by this interval, that is 0 to pi, provided this theta belongs to the interval that is minus 1 to 1. So the principal value branch of cos inverse theta belongs to this interval, that is 0 to pi. This is the closed interval, and provided theta belongs to minus 1 to 1. So we can also write this expression as theta greater than or equal to minus 1, and here we have 1. So now we can replace this theta by natural log of x minus 2. So here we have minus 1, then we have natural log of x minus 2, and here we have 1. So now we have this inequality, right? And we have to solve this inequality for x, right? Okay, so now here what we will do, we'll take all these three numbers to the power of e, where e is the exponential number. So in order to solve this inequality for x, we have to raise these three numbers to the power of e. And remember, the function that is log x to the base a is always an increasing function for all values of x in its domain when we have a greater than 1. And here we have the natural log, and it implies that we have the base of the logarithm as e, and e is greater than 1, right? So we can raise these three numbers to the power of e without disturbing the direction of the inequalities. So we can now write e raised to minus 1, and here we have e raised to natural log of x minus 2, and here we have e raised to 1. So the purpose of raising these three numbers to the power of e is that this expression, that is e raised to natural log of x minus 2, is equal to x minus 2, because we know this result, that is m raised to log of p to the base m is always equal to p if m is greater than 0 and m is not equal to 1. And here we have e, because the base of this log is e, so the value of m is e, which is obviously greater than 0 and it is not equal to 1, and the value of p is x minus 2. So e raised to natural log of x minus 2 is equal to x minus 2. So here we have e raised to minus 1, and here we have simply x minus 2, and here we have e. So now let us add 2 throughout this inequality. So we have e raised to minus 1 plus 2, and here we have x minus 2 plus 2, here we have e plus 2. So this is e raised to minus 1 plus 2, and here we have x, and here we have e plus 2. So now this inequality suggests that x is greater than or equal to e raised to minus 1 plus 2, but less than or equal to e plus 2, right? So now let us see this log term here. Here we have a log of x minus 2, right? So natural log of x minus 2 is defined for all values of x for which x minus 2 should be greater than 0, because here we cannot have a negative number, because the log of negative numbers is not defined on the set of real numbers. So we must have x minus 2 should be greater than 0, that is x should be greater than 2. So we have to now merge this inequality with this one, that is we have to identify the common region between this inequality and this inequality, right? So here natural log of x minus 2 is defined when x minus 2 is greater than 0, that is x is greater than 2. So now let us take the help of the real number line. So now here we have the real number line minus infinity and plus infinity, right? And here the first condition is that x should be greater than 2. So here for simplicity, let us represent the numbers like this, that is 0, 1, 2, 3, 4 and 5, right? And here x is greater than 2, and here it is important to note that x is not equal to 2, right? So log of x minus 2 is not defined for x equal to 2. So we have to first discard x is equal to 2. So x greater than 2 implies that we have the interval that is 2 to infinity. So here we have this reason for this interval, that is 2 to infinity, and here x is equal to 2 is not included. Now let us represent this inequality on this real number line. So here we have x greater than or equal to e raised to minus 1 plus 2. So here we can write 1 over e plus 2, and here we have x, and here we have e plus 2. Now we know that the approximate value of e is equal to 2.718, right? And the value of 1 over e, 1 over e can be written approximately as 0.3678. So we can divide 1 by e, and we can get the approximate value as 0.3678. So here 1 over e is 0.3678, and here we have 2, and then we have x, and here we have 2.718, and here we have 2, right? So adding these two numbers, we have 2.3678, and here we have x, and here we have 4.718. So our x, it lies between these two numbers, including the endpoints, right? So 2.3678, it lies somewhere here, right, between 2 and 3, and this number 4.718, it lies somewhere here. So we have this reason, that is this inequality can be represented like this, including both these points, right? So 1 over e plus 2 is approximately equal to 2.3678, and e plus 2 is approximately equal to 4.718. So the representation of this inequality on the real number line is given by this line. So now we have to identify the common region between these two regions, that is first from 2 to infinity where 2 is not included, and from 1 over e plus 2 to e plus 2. So this number is 1 over e plus 2, and this number is e plus 2, and from these two regions we can easily conclude that this portion, that is this interval x belonging to 1 over e plus 2 to e plus 2, is the region which is common to these two inequalities, right? So the domain of this function is given by this region. So this interval which is closed from both the ends gives us the domain of f of x, and the domain is given by this interval 1 over e plus 2 to e plus 2. Hello viewers, in today's session we are going to discuss another important problem from domain of functions, and here we are to find the domain of this function, that is f of x is equal to square root of 1 plus natural log of 1 minus x, right? So let us see how we can find out the domain of this function f of x using some concepts from a logarithmic function. So now see, we have to find all the valid values of x for which this function f of x is defined, right? So the first thing here we have to keep in mind that square root of 1 plus natural log of 1 minus x, right? So this term inside the square root sign must be greater than or equal to 0. So the first condition is that 1 plus natural log of 1 minus x should be greater than or equal to 0, because we cannot have this term as a negative term, because the square roots of negative numbers are not defined on the set of real numbers, right? So this term 1 plus natural log of 1 minus x has to be greater than 0 or equal to 0. And the second condition is that this term, because 1 minus here we have natural log of 1 minus x, therefore in order to define the term natural log of 1 minus x, this term, that is 1 minus x, has to be greater than 0, right? And here it is quite evident that x cannot be equal to 1, because when x tends to 1, then natural log of 1 minus x tends to natural log of 0, right? And natural log of 0, it tends to minus infinity. So here we cannot take x is equal to 1, and here we should have 1 minus x greater than 0. So we have minus x greater than minus 1, and here in order to get rid of these two negative signs, we have to multiply this inequality both sides by negative 1. So the direction of the inequality gets reversed, so we have x less than 1, and x less than 1 implies that x should belongs to this interval, that is minus infinity to 1, right? So here in order to get the domain of this function f of x, we have to take care of these two conditions. So 1 plus natural log of 1 minus x should be greater than or equal to 0, and here 1 minus x should be greater than 0. So here x belongs to this interval, that is minus infinity to 1. So here we have the real number line, minus infinity to plus infinity, and here we have 1, right? So let us represent this interval on this real number line. So here we have this region that is from minus infinity to 1, and remember here 1 is not included. So now let us solve this inequality. So here we can now write natural log of 1 minus x is greater than or equal to minus 1, and now here we have natural log. So what we will do in order to solve this inequality in for x, will raise these two quantities to the power of e, that is we'll take e raised to natural log of 1 minus x, and here we have minus 1, so we have e raised to minus 1. So here we have used this concept, that is a log of say x to the base a, where a is greater than 1, then this function is an increasing function, right? And here when this function is an increasing function, then the direction of the inequality, it remains the same, right? So now here e raised to natural log of 1 minus x is simply 1 minus x, because we know that e raised to natural log of p is equal to p, and here p is 1 minus x, and here we have e raised to minus 1, that is 1 over e. So here we can now write minus x greater than or equal to 1 over e minus 1, and again multiplying both sides by -1, we have x, and then we have here the direction of the inequality get reversed, and we have 1 minus 1 over e. So we have x less than or equal to e minus 1 over e. So now let us find out the value of e minus 1 over e. So we'll find out the approximate value of this expression, right? Because here we have x less than or equal to e minus 1 over e. Now we know that e lies between 2 and 3, and the approximate value of e is 2.718, right? So if we substitute this value of e in this expression, we have 2.718 minus 1 over 2.718. So now if we calculate this expression, then e minus 1 over e is approximately equal to 0.6322, right? So here x less than or equal to e minus 1 over e may be written as x less than or equal to 0.6322. So now the solution of this inequality is given by this interval, that is x belongs to the interval that is minus infinity to e minus 1 over e, and here we have closed, right? This is the closed interval, and it is open from the left and closed from the right, and e minus 1 over e is approximately equal to 0.6322. So we can now write minus infinity, and here we have 0.6322, and from this real number line, here we have say 0, and 0.6322, it lies somewhere here, right? So this point is e minus 1 over e, right? So the solution of this inequality is now given by this region, right? And here obviously this point is included. So here we have the solution of two inequalities, that is here x less than 1 is given by minus infinity to 1, and x less than or equal to e minus 1 over e is given by minus infinity to 0.6322. So now let us find out the common region, right? So now we have to identify the common region between these two intervals, that is from minus infinity to 1 and minus infinity to 0.6322. And from this real number line, we can easily see that the common region is given by this region, right? So here we cannot take the region from e minus 1 over e to 1, so only this part, right? So from minus infinity to e minus 1 over e is the common region between these two intervals. So the domain of this function f of x is now given by this interval, that is from minus infinity to e minus 1 over e, or we can also express the domain by this inequality, that is x less than or equal to e minus 1 over e. So this is the required domain of this function f of x.